Chapter 12, Crystalline Solids. Exercise 12.85. The volume of a unit cell of calcium is 0.173 cubic nanometers, and the density of calcium is 1.54 gram per cubic centimeter. Part A. Find the number of calcium atoms in a unit cell of calcium. How do we tackle the problem? We're given the volume of a unit cell, we're given the density. Provided these two pieces of information, we should be able to get the mass of calcium in a unit cell, and then divided by the mass of a single calcium atom, we should be able to find the number of calcium atoms. Now let's work on this. So first, mass is equal to volume times density. We'll use this equation to get the mass of the calcium atoms inside one unit cell. And we have the volume here, which is 0.173 nanometer to the power of 3. So we'll have to replace volume with this value, and then we have density. Alright, so this is the setup. That's going to be the mass of the calcium atoms inside the cell. However, when we are looking at this, this is nanometers and this is centimeters. So we'll have to do some conversion. 1 nanometer is 10 to the power of -9 meters. So over here, let's just use meters. Alright, and it should be cubed. So this whole thing is cubed. Alright, now we have 1 cubic nanometer equals 10 to the power of -27 cubic meters. And over here we do the same thing, but 1 centimeter is 0.01 meters. So over here, this is going to be 10 to the power of -2 to the power of 3. Alright? And now we'll have the total mass of the calcium atoms inside a unit cell. And then this number, I'm gonna have a pair of parentheses over here, divided by the mass of one single calcium atom, which is the molar mass of calcium, 40.08 gram per mole, but this is per mole. I need to convert it to per atom. Now let's look at the setup. On top we have the volume of a unit cell in cubic meters, because I converted nanometer to meter. I converted cubic nanometer to cubic meter. And also this is the density with conversion from centimeter to meters as well. Each centimeter is 0.01 meters. So we have to have this conversion on the bottom. We have grams on top and grams on the bottom. They cancel, and now we have a number 4 here. It's very close to the integer 4. Therefore, we have 4 calcium atoms in the unit cell. And very likely, since we have this number 4, it might be face-centered cubic unit cell. Let's review the setup. On top, I have the mass of the calcium atoms in one unit cell. The bottom, that's the mass of one calcium atom. And after we do the division, we get the number of calcium atoms inside one unit cell. I think the difficult part is to do the conversions. I converted 1 nanometer to 1 meter here, and then to the power of 3. I converted 1 centimeter to 0.01 meters here, and we need to take that to the power of 3 on the bottom in the density of calcium.